Hey everybody, so this lab is about the coming week's lab is about lab 6 introduction to lenses. I'm preparing this preparation here on Google Drive because I was not able to send you guys my file earlier because my Word has not been responding, so I had to kind of you know troubleshoot. Anyway, so this lab is about using a lenses and then exploring about the formation of image using converging and diverging lenses. Students are going to be using simulation. So this is the link for a simulation here. uh, Part one is predicting. So basically this lab, in the first part is like they are going to you just make a prediction about what happens when object is at a distance same as the focal length of the lens. That means when object is at a focal point. Second is when object is at a distance twice as that of a focal length, so the distance from lens and the distance between the lens and the object is now 2 times of f, right? And then number 3 is when object is at a distance is smaller than the focal length. So basically the object will be in between lens and the focal point. So and then number 4 here just the repetition of these 3 steps for diverging lens. So this is just the prediction part. Actual lab workout part starts from here. For this lab, so students are going to use this simulation. Let me see, I thought I had opened this. Let me go over there. So this is the simulation here. Is pretty friendly, user friendly. So students are going to use, first they are going to choose the converging lens. For now it's already in converging lens here. And then so let's say students are going to look at what happens when object is at a focal point f, right? So the image formed is at infinity here, right? Image is really at infinity in comparison to where the oh no, sorry, that is not true. So you have to be careful here. So now the object is here, right? Like, so image is this is kind of, let us see. Okay, yeah, so image is formed at infinity. Okay, and then they move this to this distance. Of course they are gonna make they will see something different. And when object is moving between focal point and lens, and then this image formed is now here virtual image, and this is really the setup for magnifying glass. Okay, so students have a data here for focus height. So here the data for object distance, object height, image height is given here. Focal length is 20 centimeter. And if we go back, is that the document I'm viewing? Okay, so here they are also asked to calculate the magnification, where magnification is given by h dash by h, where h dash is the height of the image, h is the object height. So I did this for here is for one of the data, for one of the setup, and this was when the object is as 2f. Okay, so magnification is about minus 0.0 minus 0.99. Negative means the value diminishes, right? Like the size of the image diminishes. Here students are asked to find, so they measure the focal length, meaning they record the value of focal length from the simulation, but they will also record the value of the image distance. Object distance is image distance is dash, and then by using this object distance and image distance they can calculate this value of focal length and then make a comparison between those two values. So do your two values agree with each other? Answer should be yes. Oops, oh, can I not edit it again? How can I not edit now? Oh, I guess I'm gonna be editing. Okay, okay, so answer is yeah. That's not what I was trying to write here. Answer is yes. Yes, this okay. And from the data table we see the f focal length is 20, so that's a little bit 20.09 centimeter. right? So close value, they can find percentage error if they want. So this is done here, and then they're actually average the value of f found in above question, and calculate percentage error between the average value of the f from table 1. Okay, between this average and the value of f from table 1. So basically, maybe the average the value of for f found in above question. So right, they are going to have a 3 different step there, so they should have a 3 different value of f here, and then using that average value of f, they can find the percentage difference between the average value and the value of f from this table, which is 20 centimeter. So that is it. So here is a data table for students. They can use it here. It's f, right? They need to note down the focal length, object height h, image height is dash, object distance s, image distance is dash, and type of the image form, whether it's real, virtual, or or none of the image is formed. They may say none here, even though the image is actually formed when the object is at distance at f, but the image is formed at infinity, basically. Okay. And then it is inverted. That is actually, you can see in the simulation, if you have this object over here, so this arrow does, so image forms this way, but it forms at like infinity. I mean, if you bring this, of course, closer to exactly at f. Okay, somewhere, yeah, somewhere there. Okay, so so that's about it. So this is the steps. So they have to, I have a data set here for a 2f also. I haven't done the data for object distance less than f yet. So you could maybe try and keep a sample. I mean, if you have time, you could probably try this out and let me know as well, but it's all right if if you do not get to do it. Part 3 is about diverging lens. I did not collect I didn't have enough time to collect the data for the diverging lens. So basically here, they are just going to, use the, instead of converging, just use the diverging lens and repeat the process for this. And then the research question here, research question is, part 4 is research question. So just like what questions they have about lenses, using the simulation, come up with the process to obtain your, data to your ends. Come up with the process to obtain data to answer your question. This I do not know. I guess, oh, see what happened there. Sorry about that, guys. Okay, now that's when, with the time remaining, follow your procedure, just like, and come up with an answer for your question. Post-lab discussion, when object is at a focal point f, the image formed by converging lenses, where it is at, basically it is formed at infinity. Number 2, when does a converging lens act like a magnifying glass? When object lies in between lens and a focal, focal point, and then what type of image does a diverging lens form? It forms virtual image. Okay, so this is about the lab 6, introduction to lenses. I think this lab should go, oh, one thing, it would go smoothly, but student, at least in the lecture I'm teaching, in the section I'm teaching, my students, they don't have knowledge about lenses yet, because we are not there in the lecture yet. So it may take some time for them to, I think we need to give them a little bit of intro about the lenses, or ray diagram and so on. Okay, so that is about it. For the record, let me see if I can turn this off. Where is my, okay,